Hello, everyone that's just joined. We'll just wait another minute or so just to ensure anyone that's running a little bit behind can jump on. Just bear with us for a second. Alrighty, I think we could probably get started here. First of all, good day, and thank you for joining us on this webinar here. Today we'll be discussing the topic of the Toolbox approach to robotic inspections, presented by Rick Nord. Firstly, I just want to, being Australia and Southeast Asia based, I just want to send out thoughts and well wishes to everyone that's dealing with the global pandemic that we're all experiencing. I know it's a continued thing that's going across the globe, so thoughts and well wishes to everyone and how we're all having to deal with it. Today, I just want a quick introduction to myself. I'm the host of this the webinar today. My name is Cooper Smart and I'm a solutions engineer here at Nexus. I've been working closely with Rick for quite some time in here at Nexus, and we work with basically the handler of technology and the customizations of technology. Rick is the global technology manager here at the Nexus, and he works with a lot of the customization and bespoke solutions that we do with our technology. Today, he's specifically going to be presenting on the topic of custom integration of our robotic systems and how we help our clients with an end-to-end solution and handover. I'd just like to mention that we've got some upcoming webinars over the next couple of months. These cover and demonstrate our broad technologies that we cover here at Nexus. There are various topics that we kind of deal with on a day-to-day basis. So if you're interested in them, you will notice them popping up via LinkedIn, or you can contact us directly if you'd like to join them. Also, this webinar will be recorded and also future webinars, so you'll be able to watch these at a later date as well. Throughout the webinar, ladies and gentlemen, you're more than welcome to post any questions. If they are at the time, if I can grab Rick, we can stop and ask him a question, or alternatively at the end we'll leave some time for questions and we'll post them to Rick, and he'll be able to answer them all for you in a timely manner. So there is a messenger or conversation chat box at the bottom of your Zoom interface there. You can chime in and feel free to put in questions for it at any time. So I'm just going to give a quick introduction to Nexus and who we are as a team. So first and foremost, Nexus is a technology provider. We work closely with a lot of industries here in Australia and Southeast Asia and across the globe, primarily oil and gas, mining, aeronautical, defence, just to name but a few, all the way down to local municipalities. We support a large range of groups with the technology that we provide. Our main focus of the business is to provide the latest in technical solutions. We want to offer the latest and advanced RBI, NDT, whether this is basic NDT through to advanced NDT practices, and robotic platforms and the latest solutions with them. Nexus bolstered itself as a end-to-end solution provider. We pride ourselves on offering a proper handover solution to our clients. And this is ensuring that new technology is introduced to clients with the support that is required, be this training, service and support throughout, and the validation of new technologies to ensure that when a client adopts a new practice, that they meet the requirements and outcomes that they've set out. Throughout, from the beginning, Nexus was an equipment supplier, launched in 2014, basically adopting what we found at the time, the latest technologies in RVI and NDT practices. And from that, we've grown into a customization and solutions provider. We now move into our robotic platforms and customization to provide further solutions to our clients as the industry is expanding. And this is how we've grown both vertically and horizontally. Horizontally, as we can see here with our two other arms with our sister companies, 6D and Lab 61. 6D is our custom engineering and rapid prototyping manufacturing arm, and they help with our bespoke solutions. Lab 61 is our registered training organisation, and they help us with day-to-day technologies that we hand over to clients, as well as our latest technical solutions, and ensuring that handover is done with the required training. We've recently expanded to both Singapore and Houston to increase our global footprint. This way we can support our clients on a timely manner from a global scale, which also helps with us bringing on board more technology and knowledge. As I mentioned previously, our end-to-end solutions is our focus. We like to offer to our clients the service of being at the beginning of the scoping of works. This enables us to offer and advise the best technology and solutions from what we've got in our fleet, but also from what we've seen out in the field. And we find this really helps because it is a more efficient practice, and that way we can help our clients get to a solution in a more timely manner. Whether we have this solution on board, whether it's going to be a custom solution or something that we can help them source, is all part of how we like to offer an end-to-end solution. Part of our growing and global scale is the partnerships that we've formed along the way. We have both partnerships in suppliers and partnerships in who we support, both service providers and end clients. These partnerships with our suppliers have helped our end clients because we are able to offer flexible solutions. We build our model became from a rental and supply framework to being more of a leasing and on-the-spot solution provider for our end clients. This gives them flexibility, gives them ability to grow, and ability to keep exploring new technologies. As there's always something new popping up, we try and offer as many solutions as possible to all our clients. So that is a quick summary of Nexus. If you have any other questions relating to that, we can more than happy to take a phone call and discuss how we can help you with anything that you need. I'm going to move into the webinar now. So the Toolbox approach to robotic inspections. This is something Rick was working closely with the team of engineers here, and is something that he's been really passionate about for some time. So I'm going to pass over to Rick now.
Thanks, mate. Hi, everyone. I see a couple of familiar faces, actually. Thanks for joining. Appreciate it. As Cooper said, so my name is Rick Nord, Global Technologies Manager at Nexus, working from home today. I guess I want to keep this webinar relatively high level, and it needs to convey a couple of things for me. So one of the key things for me is getting in touch early, and I'll talk along the way, I'll talk about it, and I'll talk about how to do that. But one of the key messages I get from today's discussion is the earlier we start talking about a problem, the earlier we start talking about a scope, the better solution we can get out there long term. So that's really sort of one of the messages I wanted you to take away today. From an agenda perspective, I've got a couple of case studies. The exact asset doesn't necessarily matter. The exact location doesn't really matter. As Cooper said, we've got a few offices all around the world now. We have some offices over east. I saw some of those guys join as well today. So for me, really, the asset name, the specific asset dimensions isn't that important. What I wanted to show today, though, is I used 3 case studies, so at least you can see we've used it in a real life environment. But I want to step you through that process of how we can go to the shelf, how we can go to our processes and start selecting different bits of kit to then make that solution work. And that's really sort of what I wanted to get across with as well. So the 3 case studies I do have is a vertical asset. So that was a solution that we worked with a client to essentially eliminate rope access. So they used to do this asset with rope access or scaffolding during a shutdown. We were on site for a couple of other reasons. We saw this opportunity and then started the discussion. It took about 6 months of convincing, really. But I'll share a little bit on the process there, on how we went to our toolbox, started grabbing different bits off the shelf. Not everything was available off the shelf, so we had to manufacture a few things, which is where 6D came in, which Cooper also mentioned. But yes, I'll share a couple of things on that. But in my head, imagine that as a vertical carbon steel asset. If you have any similar assets in mind. The next one I want to talk about is a Subsea carbon steel asset. Same one again, the client came to us locally and wanted to inspect the Subsea pipeline. They had some big runs to do and wanted to check the valve locations. There wasn't anything available globally that could do this, just straight off the shelf. It's the same idea, engaged at an early stage, started talking about the problem, started looking at what we could do and just integrating. And there's a couple of things I want to talk about along the way. Again, we went to our toolbox, a couple of the processes we have in place to then successfully complete that, that inspection as well. And then the last one, so we've covered vertical, we've covered subsea, and the last one I want to cover is horizontal. So same idea, horizontal carbon steel asset. The case study I want to share there is a dam that was recently inspected. Same idea, they would usually do that with scaffolding. They'd have to shut the asset down, build the scaffold, do some spot readings. We heard of this opportunity again and started working with a client on how can we reduce the time to carry out that inspection. So this is the 3 case studies I want to focus on. But for me, it's I want to show you the capabilities. So I guess I want to show Nexus capabilities, but also capability if people have a discussion at an early stage. I guess we have 2 approaches. Sometimes we get people saying they want that kit, they want it tomorrow. Okay, and then we work with that. I guess our approach is more, okay, we have a problem. It's a month away, it's 2 months away, or it's a week away. Is there something off the shelf? Can we work with that? If we can't work with something directly off the shelf to rent out, can we do a couple of small modifications? So that's where our engineering group comes in. That's where 6D comes in. And I'll share that in case study 3, where we actually manufactured some parts as well with 6D and our 3D printer to get these different bits in the toolbox all together for the inspection. But yeah, just want to show you that the wider capability and sort of want to focus on technology. So we can dive a little bit deeper into the NDT side of it if there's questions around it. But I want to try and focus on the technology we sort of worked through along the way. I made a pretty big assumption you can hear me, Cooper. I figured at some point you'd actually tell me.
Got you loud and clear, mate. No problem at all.
Yeah, sweet. Otherwise, I was just talking to myself for the last couple of minutes. Okay, so the first challenge, I guess, came to us. So vertical, it was a dryer at a local site. As I was saying, so we had a couple of other scopes we were helping a couple of service providers with. And in passing, it was a lunchtime conversation. This asset came up. It was a critical path in the shutdown, and it was going to be inspected with rope access because there's some concerns in the carbon steel about 26 meters down where the product sort of comes through, flows and hits that surface specifically. So there was a concern that we're going to do rope access, critical path. I guess we were there with robotics in any way, and we started the conversation, started the engagement to then look at, well, how do we get people out of that asset, and how do we get this asset off the critical path? Because the plan during the shutdown was to do the NDT, do some cleaning along the way if needed, but then actually remediate the asset depending on what's going on, do some cutouts, get some new pipe in, do some fit outs to then get this asset back to being able to run the dryer section of this. That's sort of on the right photo. So a couple of, I guess, details on it. 30-meter high asset, carbon steel. It was about 1 meter in diameter, and wall thickness ranged from about sort of 10 to 15 millimeters. Just done locally here in Perth.
Rick, if I may, I'm just going to try and talk up because we've got a large amount of ranges coming down. Was this a recent? This is a recent job that you went and did with the team, wasn't it?
Yeah, mate. Yeah, it is. So we actually did this in early June. I guess you raised an interesting point around. I should maybe touch on that now. Actually, it's a good question, mate. So we would support as part of our end-to-end solution. That early engagement is really, really important for us. We make sure we get the best technology to site. We make sure everyone understands the limitations. We make sure we have a clear scope of work. Sometimes that even that part's pretty hard. We have a clear scope of work. Damage mechanisms are clearly defined. The coatings, the asset wall thicknesses, how we're going to enter the asset, how we're going to retrieve that asset. All of that's clearly defined at a very, very early stage. And then we look for equipment. So if the equipment is available off the shelf, fantastic, we go and grab it. If the equipment's not available off the shelf, or there is available off the shelf and there's a couple of small mods we need to do, we'll do a couple of modifications. And then the last one is the full custom development. So with all those things in place, the next step is then actually going to site. So then your question then, Cooper, so yes, went to site with this one, but it was really to train the service provider. So there was a service provider already engaged here. They've got a contract. That's not really where we want to come in. We're not service providers. Where we want to come in is the technology. So we're happy to have the discussion first up. We engaged with the service provider. We engaged with site to make sure everyone's on the same page. And then I went to site with one of my colleagues, and it was essentially training them how to use this equipment. Because when this job comes up again, or when a similar job, there's actually another job next month, they'll be doing that work. So we don't have to keep going to site. That's not what we're trying to do. We encourage and I guess provide the training to the service providers. But yeah, mate, you're right. This is one I went through very recently with Alex.
Thanks, mate. Yeah, I guess it's part of that handover that we want to make sure is done in the best form as possible, you know. So that's good. Thank you.
All right, mate. Yeah, so on the left-hand side, little entry, so about 1.5 meters. Not in this photo, but it was scaffolded off and bits and pieces so you can't fall down the hole, essentially. So we had some access on the side. I'll show you in the next photo on how we did this one. All right, so a couple of images to show you the site setup. Pretty cold day, actually. It was. It looks beautiful and sunny, but I can promise you it wasn't. Sort of 30 meters up. Wind was blowing. We were sitting there with pretty thick jackets. But the solution was a magnetic crawler. There was a couple of things we had to change. So they wanted a high definition image and continuous B-scan readings, which the crawler by itself just couldn't do off the bat. So had to look at some high definition cameras to incorporate. There's also different tethers. So this can come with different tether lengths. Because this asset is 30 plus meters, I had to look at a different tether to make sure that when we do the inspection, we can get the full vertical run. So a couple other things we had to look at. And then water supply, so interesting one, 30 meters up, there wasn't any water. So one of the things was working quite early, and it seems like quite such a silly thing, but working very, very early with the client to make sure we can get enough water 30 metres up so we don't stop the inspection. They allowed for a day. That's including arriving on site, getting all the permits done, getting the equipment to site, and then doing the full inspection. So it was a full HD video inspection. And then I'll show you on the next slide, we took some C-scan readings as well. But this is, I guess, is a really good example on the left-hand photo, sort of bringing all that toolbox items together. So we used an off-the-shelf crawler, but looked at a different tether to make sure it's the correct length. There was a pump system that would then have to run with this kit. So there's an OmniScan, so the floor detector just to the right. You might be able to see my cursor. To the right, the OmniScan. That doesn't normally work or is integrated with the bike. There's normally another kit that goes with it. But one of the service providers' requests was, can we use an OmniScan? It can do nice B scans. That's what they're familiar with. So there's a couple of things we changed. There's connectors you have to change. There's encoder terminals and plugs as well that you need to change to bring it all together to make sure the solution can get off that critical path, and then we also don't have to put people in. I'm trying to think, that's probably it for that one. I'll show you some of the results just on the next page. Okay, so the image on the bottom left, this was an image for the HD camera. So a couple of things they were looking for at the time. So it comes standard with an SD camera, so we had to engage a couple of people and have a look at our HD camera. How does that integrate? The mount on the crawler wasn't suitable, so we had to do some upgrades. Work with 6D, which is that sister company Cooper was talking about. So we did the engineering, worked it all together, and then brought the solution together. But this is a HD image to show the internal surface. Interesting one with this one, we didn't actually have to clean too much. We did an initial pass with the UT. Actually had some really good UT signal, which allowed us a little bit of extra time to do a few more runs as well. So all up, we did 6 runs. We just focused on the 4 cardinal points first. And that was really to gauge where the critical area is. So the client had an idea, but they also wanted to confirm. So worked with them, okay, northeast, southwest. You can just see on the image on the right. So north, east, and then southwest. And then we filled in at critical areas just to get the extent of the corrosion as well. So a couple of things. So conventionally, the magnetic crawler wouldn't be able to do C-scans. So with that OmniScan integration, with the training we provided the service provider, and then the couple of encoder changes we made, we could then do a high definition C-scan. So every 50 millimeters, it would take a reading, and then that would get recorded automatically as well. It would save an A scan, it would save a B scan, and then we'd integrate lastly, we'll save it all together as a C-scan. But yeah, just a nice toolbox approach for a solution that they can keep using. So the next step for this one is there's actually some more scope next month, where that service provider will be using this exact same equipment to again remove scaffolding, they're removing rope access, and taking it. There's part of the shutdown still, but they're removing it off the critical path. So that's a key part for us, is just keep working to try and remove this off the critical path. Does that make sense, Cooper?
Yeah, it makes really good sense. And I think, as you just explained throughout that, is working with the team on site throughout this handover and initial training, you worked through a few little intricacies as you moved into a C-scan, and you were able to work with those guys on site. So I think that for the next time that they employ the equipment to do this next scope, those little things that pop up have now already been resolved, and they can kind of hit the ground running, and it just makes it look far more efficient for those guys on site. And I think that uses our expertise and knowledge to really make the whole thing a little bit more seamless. I think for anyone on site, that's probably one of the most important things.
Yeah, they'll use the same tech. So there's they've dedicated techs now and stuff as well. I guess just as an outcome from this one, so we presented the, and by we I mean the service provider and us, we came in as a collaboration group, sat down with a client that same day and presented the data. And it allowed them to do a couple of things. They could see that, okay, there is a problem. They could see the extent of the problem. But the last step, when we started looking at this, one of the guys on site actually suggested just to cut the asset and rotate it by 180 degrees because the north side was still in really good condition. It was the south side which was getting damaged by the product. So yeah, quite an interesting example. We were happy to sort of do the results that day, sat down, and then what was going to take about 3 or 4 days to cut out, get some pipe, weld it back in, test that again. They essentially was a single cut, rotate, and then weld it back into place. Yeah, quite an interesting outcome from something like that as well. Just see on the bottom left, sorry, one of the other things we integrated as part of the toolbox, a high definition string. So we, on the crawler, when we originally ran some trials in-house, we couldn't, it's really hard on the crawler to see what vertical straight down is, especially if you're trying to run your paths. So we incorporated, just as part of the toolbox, incorporated a string that we could then follow. The other thing that helped was we started dropping water down. We could use the water as well. What the string then ended up helping with, which was actually something we only thought about really afterwards when we started looking at the video, was that string, because we placed it at the northern location, that then gave us a datum to go back on at any one point in time. I'll jump to the next challenge, Cooper. You happy with that?
Yeah, no, that was good. Thanks, Rick.
Okay. All right, so that was a topside job. It was vertical. Now we're going subsea, and we're going horizontal. So I guess another really interesting case study where I guess from a very initial discussion, we realized pretty quickly that there wasn't something straight off the shelf. Just a bit of info on that one. So it was 3 valves that had to be inspected subsea. So just the photo on the right, the green dots. There were 3 valves to be inspected on a 14-inch pipe. The depth of the water is about 100 meters. And the run would be from the plen up, and so deployed by divers. It's a 50-meter run to the vessel then. So we would go over the side, the diver would then deploy through the entry, and then 2 valves, a 90-degree bend, and then a last valve as well. The real aim for this was to allow pigging. They had mistrust in the external indicators. They must have had some problems in the past with these, so they didn't really trust those. So that was, yeah, so high definition, video inspection, and our sole task or scope of work was to confirm that these ball valves were 100% open for picking. The other interesting thing, I just having a look at my notes, but the other interesting thing was there was a piggable Y piece as well that had to be transversed. So it's just, imagine a Y piece that would then come off, so it's an off-take at an angle. Another really interesting one for a crawler that any one of the conventional off-the-shelf crawlers wouldn't be able to do that Y piece. Unless you can do some steering, you might get offset into the wrong pipe as well. So that was another interesting sort of conversation that we had on site. So early engagement with this one, sat down with the client, looked at the problem. They had a really good developed scope of work actually, so that made life actually a lot easier. But there was a couple of things we looked at. Okay, so why do we have to deploy from the plen side? How do we work with the divers? What do we need to integrate with the divers? What sort of fittings, what sort of handles, strain relief, and a couple of guides on what's the top of the crawler, what's the bottom of the crawler, a couple of little things we had to incorporate for the divers, and then also umbilical length. So even though the depth of the water was only 100 meters, because we were doing the inspection from a distance, we had to allow for significant, it was about double the length of umbilical as well. So just an early engagement sort of really sort of walk through all of those steps as well.
Yeah, I remember this one quite well, Rick. I know we spent quite a lot of time in-house preparing for this, and specifically that Y section, having a mock-up in the workshop and running through that section numerous times. And I remember the entry into it was fine, but the retrieval was the more difficult one, and something that we had to rehearse quite often. And I know another one that we spent a bit of time on as well was communication between topside and the divers, because for them it was a new tool, and it was trying to explain methodology and process from topside to downside over a radio channel or communication channel. I know that was something that we worked on a lot as well to make it efficient and so forth. But yeah, that was part of that practice, and ensuring that it all went well on site, and which I think it did. It was a really good, successful job.
Yeah, the client was pretty happy. And you touched on something interesting that I didn't actually have in my notes, but as part of that early engagement side, as part of sharing enough information to allow us to be part of that decision-making process, you mentioned the factory acceptance test. So one of the things we do like to do with a lot of these end-to-end slightly difficult problems is make an asset that essentially replicates the piece we're going to inspect. So that allows us a couple of things. We can make sure the tool works as expected, everything fits as it needs to. Are we missing something? Are the magnets strong enough? Are the light good enough? Does our zoom work? Is the focal length of the camera good enough? But it also allows us to essentially do an inspection before we even go to site. So we can do some training in-house of divers, so they can come around. They can actually see the equipment, they can touch it, they can see how they're going to deploy it into the pipe, how does it move, what happens when it doesn't move, but we can also show the client. So before we go to site, as part of the mobilisation process, we do a factory acceptance test. So everything gets tested, everything gets certified, gets witnessed, and then the equipment finally goes out. So yeah, quite a good point there as well, mate, around the factory acceptance test. And we do that for most of our, I guess, more complex solutions. And it helps with some of the training as well. So Lab 61 is where that comes in. And that's where some of this training for our internal people. So we obviously train our internal people. And Cooper's actually part of that. So he does the drone training. But then we also train service providers, operators. If we're selling the kit, we'll do the training for that as well.
Rick,
right, so, yeah.
No apologies. Go on. Sorry. I thought you.
So from, I guess, a solution perspective, this was really where the toolbox approach comes in quite handy. So picture on the left, you can't see my mouse if I'm on this screen, Cooper. No, I wouldn't have thought so. But you can now?
Yep, can.
Yeah, that's fine, mate. So this was an interesting one where there were parts available off the shelf. There were tested, certified, Subsea capable parts, but none of it could fit in such a way to do that pipe through the valves, through the 90 degree, through the Y piece as well. So one of the key parts of our early engagement was simulating. So as part of our SolidWorks and simulation program, we would simulate the asset, place the crawlers that we have, place the parts, place the items in the toolbox, place them in there, simulate them, and see how they would operate. So a couple of things we learned from that is this chassis that's off the shelf doesn't work. We need to develop a new chassis. So quite a bit of time was spent on developing the chassis that would allow through that Y bend, a nice short piece, you can go around that corner. And then also at the back allows this part can swindle around. So rather than being a rigid assembly from camera to umbilical, this part of the back can swindle around, which means you can go around that elbow then as well, or that bend. Same with the Y piece, so you don't get stuck in those. Same with adding weight, so traction to make sure we have enough weight for this asset to be tracking on the bottom. So we incorporated those things, and a couple of cameras as well. So there were 2 forward-facing cameras, which wouldn't come standard. So we looked at those, and we looked at a rear-facing camera, which I can't see in this photo. But there was a rear-facing camera as well. So came in handy for things like tether management, especially around the bend. So when we ran some of the factory acceptance tests, it's just having a look at where your tether is at any one point in time to make sure you're always monitoring that tether. And then lastly was the camera. So full pan, tilt, and zoom camera, obviously rated to depth, to then allow us to view these valves. Let's go through the motions for that one. A little encoder wheel, so just at the top, just to know where we are. So the umbilical feeds out, but because we're in a, obviously diver deployed through the plan, that umbilical with the encoder sits on the umbilical, wouldn't give you proper readings. So there's just an encoder attached to the system as well, just so you know where you are at any one point in time as well. But yeah, all those sorts of things, although they're available individually, minus the chassis, we're sort of bringing it all together and sort of trying to get a best solution for the client as well. Just a photo of a container. We were quite excited to sort of have a container on site, an orange container, and everything in there. So it was the simulation. There was a computer in there with the simulations on it, so we could have a chat to people and show them. There was spares, obviously being Subsea. Engaged again the client at a very early stage. Started chatting about spares. What are our critical spares? What's going to break? What's the lead times? How do we make sure that all those items are covered when we're actually on site rather than an afterthought? And then a really nice little workspace just to allow us to assemble things, disassemble things, nice and clean. When we do the O-rings, so obviously all these were pressure tested, but when we do the O-rings and bits and pieces, it was a nice clean environment. Just one more slide with this one in terms of solution. I just wanted to show a little subsea images straight off the diver cam, just to show you how it was deployed. You can see the crawler's already in. You can see the little tether. That's sort of the images we were working off when we were talking to the divers as well. Then just a little diving basket. One of the interesting things was making sure, so we got some dimensions of the diving basket. Same thing, just making sure the umbilical fits, making sure the crawler fits. Not only in the pipe, but also in the basket. How's it get deployed? What sort of little monkey's fists and bits and pieces we need to add to the system to make sure the divers can just grab it without putting any tension or any strain on those umbilicals.
And that's a neat example there on that bottom left picture, Rick, is that we had a number of cameras available on this exercise purely because, one, we needed to see inside the pipe, but we also needed to see what was happening with the divers below. So I know we equipped this project with a number of external cameras for visual inspections all around. So that was very handy as well and helpful.
It's always useful to see where you're going, especially the rear-facing camera. Originally, just with even the umbilical strain around those bends. To make sure you pass the Y piece as well was pretty handy. Part of that toolbox, throw it all together, make it work best solution for this sort of problem. The last one on this case study is just the result. So we were assuming all the valves were open. The client was assuming they're all open as well. They gave us a little valve position chart. So we did find one that was protruding just slightly. And they would toggle them as well, so they would engage, disengage, just to make sure. So there's only 3 valves the pig gets to go through. But as part of that process, we found one that was just slightly extended that they could then fix up while we're down there. It's a pretty good outcome again, I guess, from a starting point. I can jump onto the next challenge if you like, Cooper.
Before you do, I've just got a question here from Leslie, but we're skipping back to the first case study and the vertical asset. Sorry, Leslie, your questions came through just as we moved into the second topic. So Rick, Leslie's got 2 questions here. The first one was, we mentioned that the OmniScan was a preference from the client. Leslie wants to know what other UT units can we normally supply with such crawlers?
Yeah, good question. Easy answer, whatever one you'd like. We have preferences. So one of the other things we do for clients is product comparisons. So we do that with lasers, we do that with NDT equipment. We have partners where we can get equipment relatively quickly. And there's a couple of reasons they are partners, things like local calibration that we can carry out. The lead time, obviously, there's discounts and bits and pieces that come into it as well. But we're always open to have a chat about whatever floor detector people would like. Same with the probes, actually. So I didn't mention in this one, but same thing. This crawler comes with a standard probe. It's not a great probe. So we sat down with the technicians, shared a couple of our thoughts, and actually ran trials on 4 different probes for them. And we would compare the quality, so signal to noise ratio on the system, the quality of the signal. And yeah, we share that information with them, and then they can make an informed decision. But we do that with floor detectors as well. So if a client wants a specific floor detector and we have it on the shelf, fantastic, we'll use it. We can adjust the little EMO connectors that go into the kit. We can adjust the encoders that go into the kit. If there's one that we haven't got on the shelf, we might be able to suggest a suitable one, or we can engage and actually see if we can get a demo unit from somewhere. We can test it, see what's good about it, see what's bad about it, and then give you some informed report with that as well. But the easy answer, Cooper, is anyone they'd like.
Yeah.
The other thing as well is, I guess you don't have to hire one specifically. So if there's one that you actually like, we've done integrations with clients in the past where we would integrate it, whatever encoder you'd like, whatever UT probe you'd like, and whatever floor detector you might have on hand already that your technicians use. We just adjust and change.
Thanks, Rick. Just another question from Leslie, but now probably on the visual side of that robotic platform. Leslie's asked if the gimbal, if the camera is mounted on a gimbal, and can we remotely control it, or is it fixed in that forward direction? Yeah,
it is. This one's an interesting one. So all we needed for this job was to be able to look straight down on where we're scanning, because we're looking for some localized cracking, and then if there was internal corrosion. So for this specific application, the scope of work only required straight up and down. So this camera would only look, it pivots around the pivot point here, and it would look straight up and look straight down. So this one cannot rotate from side to side. But that's all the scope required. So if there's a scope of work that actually needs a pan and tilt camera, something I can show you on this one. This one's a bigger one, so this is the 120 or even the 90, but the 120, there is a smaller version of this that can quite easily fit on the top of this if that's a requirement. So that's HD as well if need be, but then that can full pan, tilt, and has optical zoom as well. We just make up a little bracket that then houses everything nicely. So this one, Cooper couldn't do the side to side, but if it's needed, mate, we just swap it out, part of that toolbox approach. Yep. There's a little bit of integration here and there, but it's not too hard.
Thanks, Rick.
Next challenge?
I think so, please.
Okay. All right, so we've covered a vertical asset, carbon steel. We've covered some subsea assets. It could be a pipe, could be a manifold, could be. I think I really just wanted to show that there are some subsea case studies as well, where we have taken this approach to work with clients on solving some of their problems, which they didn't really have a solution for. The last challenge, I guess, when I look at is a horizontal carbon steel asset. So now we're talking big carbon steel horizontal asset. I guess a couple of details on this one. So it's a dissipated dam. It was about 9 meters tall, about 6 meters wide, and I think about 12 meters long. So really the scope of work for us was to find corrosion. So they wanted to be able to find near side and far side corrosion, and then also provide a close-up visual inspection There's some coding, there's some photos a bit later on. I can show you the coding condition. So they wanted to be able to define the corrosion, find out where it was, do a visual at those locations, and then check the coding along the way as well. So traditionally, much like any of the other scopes I guess we've spoken about, they will do it manually. So they would build a scaffold. They'll isolate the dam, which there's only a certain amount of time that they can isolate it. So immediately the inspection and the scaffolding's on critical path. So they will scaffold, they'll do a couple of spot readings to get the wall thickness. They would deconstruct the scaffold and then take those readings, spend another 2 or 3 days to get the report ready. In the process, they've obviously de-isolated and the dam's flowing again. But that whole process in itself took about 3 to 4 days to sort of build up the scaffold, do the inspection, and then get some worthwhile readings as well out of it. So we had an opportunity with this one to try, the sole aim for us was to get it in such a way that we could do it quicker, but still get data the client would be happy with. So we looked at a couple of approaches, and on the next slide, I'll share those with you. Let's swing to that one. So quite an interesting one. So one of the things we haven't really spoken about is as part of the toolbox approach, we also have an equipment matrix selection. So we would look at the diameters, we would look at the wall thickness, we would look at things like material, diameters, horizontal, vertical, stick all of that in the matrix, and then we'll end up with a couple of tools that comes out of it. Now, sometimes a matrix says it can't be done. So that's when we start looking at a project like this, where we would take a crawler, we would adjust the chassis again to match the asset. We had to include a couple of extra magnets because on the next slide, you'll see the coating was quite rough. This has been in service for about 25 years from memory. So the coating's been redone multiple times. So the coating was quite rough. The surface condition was quite rough. There was some blistering along the way of the paint, but also of the material. So a couple of things we had to look at. We redesigned the chassis, put some extra magnets in, and then redesigned this front part. So this crawler by itself couldn't do NDT. So we could maybe do some UT, but we looked at then incorporating a pulsed eddy current system into that as well. So a little bit of education, I guess, to the client on what a pulsed eddy current system is capable of, what it's not capable of. One of the key things for them was being able to differentiate between internal and external corrosion. So we shared a couple of ideas on how we do that with pulsed eddy current. They had a service provider that was sort of happy to work with us to try and get this all through without having to do the scaffolding. So early engagement again, we looked at the problem, and then through the 6D, through the rapid prototyping, through the 3D printing, made this little bracket up, and I'll show you in the next slide. There's a couple of photos of those. Pulsed eddy current, so it takes an average wall thickness of the area. So they were looking at general corrosion. So we're not talking isolated pitting, we're not talking weld inspection with cracking. They just want a general corrosion mapping. So a very easy solution to not have to worry about a couple of things. So the coating condition, we had some trials and it was quite hard to get UT readings through some of this coating. We also looked at the blistering. So they were quite interested in some areas that had blistering in it. Same thing, unless you can clean it, unless you can buff it clean for UT, there's a bit of a limitation there. And then the water as well. So it wasn't too hard with this one, but again, quite a remote site. You'll think a dam has water, but they've isolated everything. So the water wasn't a major problem. But the sort of couple of things we looked at was the coating and the surface roughness. And that's why we suggested pulsed eddy current, which we then attached to the system. Makes sense, Cooper? Yep.
Yep, no, excellent, makes good sense, thank you.
Yeah. I'll show you, so yeah, it took a couple of weeks, sort of from chat to site. One of the interesting things with pulsed eddy current is it will get affected by anything ferromagnetic. within what's called its footprint. So close to the probe, anything ferromagnetic will get affected or will affect the readings. So one of the interesting things we had to do was actually extend all this out. So stainless steel springs, 3D printed little arms that could be attached, incorporate the umbilical and lights and bits and pieces that comes with it. But keep this probe far enough away from anything else that's ferromagnetic, including magnets that's sitting right next to it. So there's a couple of considerations that we just have to do a bit of, I guess, tests along the way, factory acceptance tests, make sure we're on the same page, make sure the client understands, and then we went and did the job. So the job itself took less than a day, and we got some really good readings out of that as well. The really nice thing about this was you could then look at that data live in a C-scan and essentially make an informed decision before you even have to de-isolate. And the client was quite happy with having all that whole process, would normally take sort of 3 to 4 days, get that done in less than a day, and actually see all the results as well. You can see, I'll show in the next slide as well, you can see some of the areas where the coating's been reapplied. You can see surface roughness just on the bottom left. Surface roughness where we tried similar setups with UT and just didn't have good results. Whereas the pulse steady current was quite forgiving with surface roughness. Just the last slide. So I just really wanted to show you the results. I guess just as part of that improvement that we managed to do for the clients, managed to do it quicker, managed to do without the scaffolding. So it was a reduced cost as well, reduced timing for isolation, and then the permanent record for data. So encoded readings that a client can then scan at those exact same locations again in the future and start looking at the actual degradation and see how that defect extends over time as well. So a couple of interesting readings. So this is in percentage. That's how the client prefers it. We could do it in percentage or millimeters for pulse steady current. But there's a couple of, it's out of 100. So there's a couple of really low readings. We identify for the client, and then they are going to have a look at those on what the cause is. That's it from my side, Cooper. I'm not sure if there's anything else you want me to go through.
No, that was excellent again, once again, Rick. I think this was another one, as you expressed there, was that early engagement, as we could walk through the intricacies of doing such NDT practices and where we moved down to the pulse steady current. I think that was a real benefit for this. Otherwise, they were, I think, left scratching their head a little bit on how they could do this remotely. So
they're going to keep doing this. I think it's a yearly inspection. It's the same thing. Service provider they want to engage was there on site with us. We showed them the UT sort of exercise. We showed them the pulse steady current. They know now. They now know how to do pulse steady current. They understand it. So there's some training implemented for that. And then it's just a yearly exercise now. But from our side, our engagement is making sure they're happy, but then get the kit to them, and they actually do the work on site. So a pretty good win for everyone along the way.
Definitely. All right, Rick. Well, thank you for sharing that with us. We haven't got any further questions here right now. If anyone does have any further questions that may arise on these specific topics or similar topics, please feel free to get in contact with us directly. We're more than happy to sit down and discuss a possible solution. I hope it's all been valuable learning, and that this webinar you can walk away with some information that you can take to your team and possibly come up with some challenges that you can present to us, and we'd like to work through with you. So I think we'll leave it there today. As I said, we've got some further webinars coming up in a couple of weeks, working into some of our other areas of the business and the broader scopes that we do. So keep an eye out for them. They'll be, I think, posted on our LinkedIn page. And if not, get in contact with us directly, and we'll be able to sign you up for them and keep you notified of when they're happening. So from here in Perth, thank you for joining once again, and we'll look forward to talking to you guys soon. Stay safe.
Thanks, Cooper. You just have to exit from that spot as well, please, mate.
All right, bye guys.